Hello students, welcome to Young Cubs. We are going to start with the chapter of forces and energy. Okay, this is the part 1 and today we are going to learn a lot about density. Let's start. Okay, now children, basically before explaining the term of density, first of all you guys need to have a clarity of the word mass. Okay, mass is defined as the measure of how many particles are there in an object. Okay, so if you have a pencil, how many particles it is made up of is the mass of that particular pencil. Okay, if you have say a small what do you say, a small grain of rice, how many smaller particles is the grain of rice also made up of is the mass of that particular grain of rice. So the number of atoms, to be very precise, atoms and molecules. Okay, so the number of atoms and molecules present in a particular object or a substance is the mass of that particular substance. And as you know, mass is measured in kg in the system international unit, and it is directly proportional to the density of the object. I will come to the term density. I will come to this slide once again. So, children, giving more clarity about mass. So, what is our mass is very different from what is our weight. Okay, mass means the number of atoms and molecules we are made up of. Okay, but the pull towards the earth, the gravitational pull towards the earth, okay, is approximately 9.8. Okay, 9.8 newtons. So the number of particles multiplied by 9.8, which is the gravitational pull or the gravitational force, makes up our weight. So children, do not confuse mass with weight. Okay, mass is the number of particles, and when you multiply the mass with the gravitational pull, it becomes your weight. So right now, while before talking about density, remember we are talking about the number of particle that particular object has. Okay, it is measured in kilograms as per the system international unit. Okay, then before again talking about density, we have to know what volume means. Volume is the amount of a three-dimensional space. Okay, three-dimensional space means any space that has a length, okay, a width, and a height. So it becomes a three-dimensional a three-dimensional space. So any space that you can fill up with, okay, is the volume. Okay, it is the space that an object will take or will occupy. Okay, so the amount of a three-dimensional space that a substance or object occupies, or the amount of space inside a container, is the volume. Okay, is the volume of that particular object, the amount of space occupied by, okay, those particles. Is the space is the volume. Now volume is measured in meter cube, okay, or cubic meter in the system international unit. Okay, and it is inversely proportionate to the density. Okay, I will come back to this slide as well to explain what is inversely proportional to the density. Okay, now, okay, what is density? Density is the quantity of matter, okay, packed into a unit volume of material. So quantity of matter means nothing but the number of particles, the mass, okay, packed in a particular space is the density. So the space occupied by the number of particles, space occupied by the particles or by the object, okay, it can be measured in the space, or the mass will be measured in kilograms, okay, per cubic meter, or in grams per cubic centimeter. So density, okay, the unit of density could either be kilograms per cubic meter or grams per cubic centimeter. So density is a property that can be used to identify a substance. It is a physical property. Okay, it is measurable and it is a physical property. Okay, each substance has a unique density. So by these definitions, coming to the formula of density, it is density is equal to mass upon volume. So that if there is a particular space, okay, if there is a particular space, okay, the particles, okay, if I place say cotton, okay, I fill up this box with cotton, okay, so the maximum amount of cotton that I can squeeze and put inside this box, okay, will be the density of that of cotton. Or if I fill up water, okay, the maximum amount of water that I can fill up in this box or in this container is the density of water. Okay, so if I can fill up more particles, or if I can say the mass is more, the density will also be more. Okay, if the space is less, okay, if the space is smaller, okay, the density again will increase. Okay, if I take a big box and if I say pour say 10 molecules of water in it, okay, this is a small box, okay, so the volume will be, either the space that will be occupied is small, so the density of that particular thing will be higher because it is occupying a smaller space. If I increase the size of the box, okay, and I keep the number of particles the same, the volume increases, so the density, the space occupied by the water molecules or the cotton molecules will be the volume, if it increases, so the density will be lesser because it will tend to spread out all over the container. So then when density increases, volume decreases. That's why it says volume is inversely proportionate to density. If I take a larger box and keep the number of particles the same, okay, the particles will tend to spread out all over the space, or rather there will be empty space, so the particle number of particles are less, will seem less in a bigger area, so the density decreases, the space, okay, density decreases if I increase the space. And what do I mean by Indirectly proportionate, that means if I want more, if I want, if my particles are more, the density will also be more. It will be more dense. It will be more of something. So that's why density is directly proportional to the mass of the object, and density is inversely proportional to the volume of the object. And this helps us to derive this formula, which is density is equal to mass upon volume. So density is directly proportionate to mass, and density is inversely proportionate to volume. Remember, children. After this, the next thing that you need to remember is the unit of density. The unit of density is either kilogram per meter cube, or it is gram per centimeter cube. Okay, so when you need to find the density, you need to know the mass, you need to know the volume of the space occupied, and then divide the mass by the volume. Okay, think about the food containers and the nails that you must have seen in your textbook in the pictures. Okay, now the food containers are made up of polystyrene. Okay, so these, if you check, if you weigh them, okay, they are quite light. So if they are light, that means the number of particles that it is made up of is less. That means it has a smaller mass. Okay, if the mass is smaller, that means the density that it has will also be smaller, because the volume will be larger. In a unit cubic unit, okay, unit cube, the number of particles are quite less. The space is more and the number of particles are less. Okay, the containers are also hollow. Hollow means more of air spaces are there, which means that the space is filled with air. Sorry for the spelling error, children. Is filled with air inside them. The nails are made up of iron. Okay, the nails feel very heavy. Okay, nails feel very heavy because they have more mass, more number of particles in them, in a very small area. So many particles are packed in. The nails are also solid. So any which ways the intermolecular spaces between them is less. The word solid in that case means that each nail has no space that can be filled up with air inside them. Okay, the word solid can be used as the opposite of hollow. So if I say this thing is solid, that can also refer to that air spaces in them is less. One of the polystyrene food containers has a larger mass than one of the nails. Okay, however, the same volume of iron has a larger mass than the same volume of polystyrene. So that simply means if I have iron nails and I have polystyrene, okay, iron nails will have a higher mass. Okay, polystyrene has a lower mass, and it is hollow, so it has more air spaces. Comparatively, in the volume that it will occupy, the space that it will occupy will be less. And here in polystyrene, since there are more air spaces, the volume occupied is more. Looking at the iron nails, looking at more mass is directly proportional to density. Hence, mass is more, density will be more. Volume is less, density will be more. On the other hand, if you tend to look, if mass is less, density will be less. If volume is more, Volume is inversely proportionate to density, hence density will be less. All right, understood this much. One of the polystyrene food containers has a larger mass than one of the nails. However, the same volume of iron has a larger mass than the same volume of polystyrene. We use the term density to describe this difference. Okay, if something is hollow, that means its density is less. Now, how do you calculate volume? So, if you have a regular object simply means of which you can find the length, breadth, and height of. So, if I have a cuboidal object, cuboidal means it is made up all of squares. That means the length, the breadth, and the height will be the same. Hence, the volume of a cube will be side cube, correct, this side into this side into this side, since all the sides of a square, so that's how you can calculate the volume of a cube. Similarly, if we have something as in cuboidal, like in this picture, the length multiplied by the width multiplied by the height. Okay, this is where something can be filled up. Okay, so how will you calculate the volume of a cuboid? It will be length into breadth into the height. So when calculating the volume of a regular block of material, we share the lengths of the side. When talking about a block of material, regular means that we use the equation. There is an equation, there will be a regular formula if it is a regular object. Okay, so this block of wood has a regular shape. That means we can measure and find out the length, breadth, and height. So over here, the length is 10 mm, breadth is 6 mm, and the height is 4 mm. 6 fours are 24, 24 and 10 to 40. So that's how you calculate the volume. So this was for regular objects, okay, of which they have a formula, okay. The unit is mm cube. Why mm cube? Because 3 times you multiplied the mm. Okay, it does not matter in what order you multiply it. Okay, they try multiplying the numbers in a different order. So yeah, we know this, that you can multiplication and addition can be done in any order. Okay, the answer comes out to be the same. So this was for regular objects. Now, how to go about with irregular shape? So if I tend to find out the height of this height is different from this height. Yes, or this height. So we cannot keep measuring it from everywhere. We'll end up forgetting everything. All right, and there is no general rule to multiply. Every object will have a different shape, and so to find out a general rule, they do this method where you measure you measure the object within a measuring cylinder. So you take a measuring cylinder like this and you fill it with some amount of water. Make a note of the amount of water. So in this case, it is 40 ml or centimeter cube. Let me put it that way, since it's 40 centimeter cube. Then this object will be tied with a string. Okay, and then it will be dipped into the measuring cylinder like this. Obviously, the water levels will rise like it has risen here. So now, what is the new volume? It is 60 centimeter cube. To find out the volume of this object, now all you need to do is volume 2, which is the second volume, minus the volume 1. okay, will give you the final volume. So final volume of the object is 60, which is volume 2, minus 40, which gives you 20 centimeter cube. This is the formula, a general formula to find out the volume of irregular objects. Understanding, children? Okay, make a note of it. How to find the volume of irregular objects. General way or general technique to find the volume of irregular objects. Okay, children? Hope this much is clear. So then once you attain the volume, okay, you will, you've gotten the volume, mass, you will get it from a spring balance or a balance, okay, for that matter. You have to straight away put the object on the machine, whatever the machine reads, okay, the balance reads, okay, we have digital balances these days, exact, amount of mass which just has to be written on top. Volume we just looked at how to calculate. Work it out and you get the density. You write the answer and that's it. Put the unit behind. So let's read. We say that iron has a higher density than polystyrene. Density means mass per unit volume. A solid block of iron measuring 1 into 1 into 1 centimeter has a mass of 7.9. So what's given? Mass is how much? 7.9 grams. What is the measurement of the block? 1 into 1 into 1. So volume is equal to 1 into 1 into 1 centimeter cube, which is equal to 1 centimeter cube. Yes, so a solid block, this is given, okay, a solid block of polystyrene measuring 1 to 1, okay. So this is the volume of the block, iron block. Iron block. Okay, now a solid block of polystyrene measures. Okay, now the volume given again. Okay, for volume of polystyrene block is how much? Okay, mass is given as 0.05 grams. Volume is given as 1 into 1 into 1 again, which is equal to 1 centimeter cube. We calculate the density. So let's calculate the density of the iron block. The formula is density is equal to mass upon volume. Density 7.9 upon 1, which is equal to 7.9 gram per centimeter cube. This is the density of the iron block. Let's find out the density of the polystyrene block, which is equal to 0.05 upon 1, which is 0.05 grams per centimeter cube. Okay. Which is heavier? 7.9 is heavier or 0.0? Obviously 7.9. So the density of the iron block is greater or higher. Understanding, children? So here same thing has been worked out. Okay. Now let's try these. A student measures the mass of an 8 centimeter cube block. So by looking at the unit, I know that what is given? The volume has been given, which is equal to 8 centimeter cube. Okay, of brown sugar to be, okay, so the mass of this brown sugar is 12.9 grams. Oops. 12.9 grams. What is the density? Density is equal to mass upon volume, which is equal to 12.9 upon 8. Let me calculate that. 12.9 divided by 8 is 1.61 grams per centimeter cube. Understood, children? Let's go to the next sum. A chef fills a 50 ml container. What is given? The volume is given. 50 ml container. Okay. With 43.5 grams. So mass is 43.5 grams. Children, ml is as good as centimeter cube. Okay. So this can also be written as centimeter cube. ठीक है. Of cooking oil, what is the density? Density is equal to mass upon volume, which is equal to 43.5 upon 50, which is equal to 0.87 gram per centimeter cube. Okay, quite low a density. Okay, it is not very thick. The cooking oil is not very thick. Okay, it has quite a few air spaces in the cooking oil. Calculate the mass of a liquid with a density of 2.5 grams per ml and a volume of 15 ml. So what is given over here? What is given? The density is being given, which is 2.5 grams per ml. Okay, and the volume has been given, which is equal to 15 ml. Okay, we have to find out the mass. Formula: density is equal to mass upon volume. Density is given, which is 2.5. Mass is not given. Volume is 15 ml. Correct? Yes. So to find out mass, this goes up with a multiplication. 2.5 into 15, which is equal to 37.5 grams. Yes? Yeah, it's grams per. So that's the mass of the liquid. Okay, next. Calculate the volume of a liquid with a density of 5.45 grams per ml and a mass of 65 grams. So, given density, which is equal to 5.45 grams per ml, mass, which is equal to 65 grams. Okay, density. T is equal to mass upon volume, which is equal to density is 5.45, mass is 65, volume we need to find out. This goes here and this comes down. So volume is equal to 65 upon 5.45. So volume is equal to 11.93 ml. Okay, rounded off to 2 decimal places. Children, hope I'm not going too fast. Hope you guys are understanding. If you aren't, I would request you to pause the video and keep watching it step by step till it slowly seeps into your brains. Okay? Now, what is given? A machine shop worker records the mass of an aluminium cube as 176 grams. Mass is equal to 176 grams. If one side of the cube measures 4 centimeter, what is the density of the aluminium? So, volume we need to find out. So, before writing that, I think I should write side length of cube is equal to 4 centimeter. We need to find out the volume. Okay, we need to find out the density. Okay, so before finding out the density, I need to find out the volume. So volume, okay, what is the formula to find out the volume of a cube? It is side cube, which is equal to 4 cube, which is equal to 64. 4 4s are 16, 16 4s are 64 centimeter cube. Yes, now proceed to density. Mass upon volume, which is equal to, what is the mass? 176 upon volume is 64. Which is equal to 176 divided by 64 is equal to 2.75 grams per centimeter cube. Very easy sums, children. Just one formula to work with. Next, a teacher performing a demonstration finds that a piece of cork displaces 23.5 ml of water. So, ml of water, meaning now this is an irregular object. Piece of cork, okay, so it is an irregular object. Hence, the volume is already given. Okay, so mass is given, which says the piece of cork has a mass of 5.7 grams. The volume of the piece of cork is 23.5 ml. Okay, density is equal to mass upon volume. Okay, mass is 5.7, density is 23.5. Yeah, so 5.7 divided by 23.5 is 0.24 grams per ml. Okay. Now, A carver begins work on the following block of granite that weighs 2,700 grams. So, given mass, mass is 2,700 grams. What is the density of the granite if this is the volume? So, volume is equal to length into breadth into height. Length is the longest one is 20. Breadth, let me take it as 10. Or rather, breadth is shown in the diagram here. This is the breadth, which is 5, and the height is 10. 2 5s are 10. 100 into 100, 1000 centimeter cube. Yes. Okay, that's the volume. Now finding the density, which is equal to mass upon volume, which is equal to 2,700 upon 1,000. Cancel, cancel. Which is equal to 2.7 grams per centimeter cube. So far, so good, children. Yes. A piece of PVC plumbing, a piece of PVC plumbing pipe displaces 60 ml. So again, the plumbing pipe, it looks like an irregular shaped object, children. So it displaces 60 ml when placed in a container of water. If the pipe has a mass of 78 grams, okay, what is the density of the PVC pipe? Okay, let's go. So given, okay, mass is equal to 78 grams. Volume is equal to 60 ml. Okay, density. Find out. Density is equal to mass upon volume, which is equal to mass is 78. 60. 78 divided by 60 is equal to 1.3 grams per ml. A solid magnesium flare has a mass of 1300 grams. So given mass is equal to 1300 grams, okay, and a volume of 743 centimeters or centimeters, or the volume, there's some typing error, it should be centimeter cube. Yes. A solid magnesium flare, okay, can be maybe an irregular object. What is the density of magnesium? Okay, density is equal to how much? Density is equal to mass upon volume, which is equal to 1300 upon 743, which is equal to 1.75 grams per centimeter cube. So children, we've solved all these problems on a different sheet of paper with the working. Alright, do practice this at home, or do take a printout, or do take a screenshot of these sums, okay, and practice it and tally your answers with mine. Okay? Okay, the next thing is I want to teach you how to measure volume of irregular objects. So in this picture, look at this. This is an irregularly shaped object, and remember children, whenever you measure volume, okay, you need to look at the bottommost tip of the liquid. Okay, so here we are. Okay, let me erase this. Okay, so initial volume is how much? Okay, so this is 4. Let me count 1, 2, 3, 4, 5. So 20 difference 1, 1.2, 1.4, 1.6, 1.8, 2. Okay, so this is 4, 4.2, 4.4, 4.6, 4.8. So initial volume is how much? 4.8. Final volume is how much? 5, 5.2, 5.4, 5.6. Final volume is 5.6. Okay. So now centimeter cube, centimeter cube. So what am I going to do? Final volume minus the initial one. So final is 5.6 minus 4.8 gives me object volume of 0.8 centimeter cube. Okay, over here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, okay. So here this is 30, 31, 32. My initial volume is 32 centimeter cube. My final volume comes up to 38. 2 less than 40, 38 centimeter cube. So 38 minus 32, 6 centimeter cube. Going to the next one. Okay, 1, 2, 3, 4, 5. Okay, so 2, 4, 6, 8, 10. Okay, so gap of 2. So this is 3, 3.2, 3.4. Initial volume 3.4 centimeter cube. Okay, here we have, it is exactly 5. Okay, so the volume is 5 minus 3.4 gives me 1.6 centimeter cube. Let's look at this one. Okay, this is 50, 55, 60, 65. Initial volume 65 centimeter cube. 60, 61, 62, 63, 64, 65. Okay, so then 65. So this is 69. 69 centimeter cube gives me 4 centimeter cube. 69 minus 65. Okay, this is 10, 20, 30. So a gap of 2, 4, 6, 8, 10. Gap of 2. So this is 40, 42, 44, 46. 46. Initial volume is 46 centimeter cube. Children, get into the habit of writing the unit each time. Okay, 50, 52, 54. 54 centimeter cube. Difference of 8 centimeter cube. Okay, come on. Last one. Okay, it's sponge, is it? Okay, it's just exact. Okay, this is 50. So 30, 32, 34, 36, 38, 40. Okay, this is 52 out here. Okay, 2, 4, 6, 8, 10. Oh, no, it's 50. It's 50. Okay, this is initial volume is 50 centimeter cube. Here this is 52 centimeter cube. So, object volume or volume 2 centimeter cube. So, done a lot of calculations today, children. That's all for today. Thank you and God bless you all.